Hey everybody, welcome to 4E, factored form, lesson 4E. Alright, so let's dive right in. So last lesson we talked about the vertex form. Okay, so just a little recap. So far we've talked about the standard form, where the standard form only gives us our y-intercept. So y-intercept of 6, y-intercept of 6. Okay? Now notice that the a value for all three of these forms, so this is the vertex form, standard form, factored form. Factored form is what we're focusing on today. But you notice that the a value for all three of them are the exact same. In this case it's -3, so the negative implies it's opening down, and the 3 means everything is being stretched by a factor of 3. So remember our last lesson, our 1, 3, 5. So rather than 1, 3, 5, it should be 1 times 3 is 3, so it should be 3, 9, 15. Okay, so let's see if that works. So from here, from the vertex, 1 over, and it should be going down 3, 1, 2, 3. So 1, oh sorry, I lied, 1 over, so this is 0.5, so it should go to 1.5, which is there, 1 over, and then down 3, 1, and it looks like 2 is 1, so 2, 1, I'm looking at the scale here, 1, 2, 3, and if I go 1 over, that should be going down 9, and so forth. Okay, so that was last lesson. Now again, the vertex form tells us the vertex of 0.5 and 6.75. 0.5, 6.75. Okay, now what does the factored form tell us? I think I may have mentioned this briefly, but if this tells us our y-intercept, this tells us our vertex and our stretch, and our vertical vertical stretch or compression, then what would this tell us? Well, if I look at this graph, there's a reason Desmos picked up specific points here. Okay, I didn't put those in, I just typed in the equation and they showed up because these are key characteristics of a parabola. So unlike a line, when we talked about y equals mx plus b, b being the y-intercept, m being the slope, the two main characteristics of a line, a parabola has more than just the two characteristics. So we have of course, our y-intercept, our vertex, and then our x-intercepts. So this tells us one of our x-intercepts is at -1. -1, even though it says +1, you switch the sign if it's in bracket. Again, I'll explain why that is at a later date. Over here, the other x-intercept would be 2, +2, even though it says -2 here, and sure enough, it crosses at 2. Okay, so with that being said, let's dive right in. Factored form. Sorry, I'm just going to delete these 3 so we can check our answers. Number 1, the equation is y equals x minus 4, x plus 2. So what are the x-intercepts? So the x-intercepts are x equals to 4 and x equals to -2. So what are the x-intercepts? It should be, x-intercepts, remember, are coordinates. So it should be a 4, 0, remember x first, before the y, and -2, 0. Okay? What is our axis of symmetry? Well, let's think about this logically. I'm going to switch back over to Desmos. Y equals x, what was it again? X minus 4, and then x plus 2. Okay. Now, if I look at this graph, and I know that these are the x-intercepts 4, 0, -2, 0, 4, 0, -2, 0, then where do you think the axis of symmetry would be? Again, and the axis of symmetry is the line that cuts our parabola perfectly in half. Well, we learned last lesson that it clearly goes through the vertex, in this case at 1, right? Now, it's easy for us to tell that it's at 1 on Desmos, because it's given to us. But what, for example, in this case, how would I know it's at 1? Well, if that's an x-intercept, and that's an x-intercept, and we know this is symmetric, then our axis of symmetry should cut it in half. So wouldn't it make sense that the axis of symmetry is exactly halfway between both x-intercepts? So our axis of symmetry then is just simply our x-intercepts added together and divided by 2. In other words, the average, or the number right in between these two. Well, 4 plus negative 2 is 2. 2 divided by 2 is 1. Okay, which means at x equals to 1, that is our axis of symmetry. Sure enough, it is. Okay? And then our vertex, well, Desmos tells me it's 1, 9. 1, negative 9, sorry. How am I going to figure that out without Desmos? Well, the vertex, in this case, I already know one of the coordinates is 1. How do I find the y value? Well, if I know it's at 1, all I need to do is find the corresponding y value. So couldn't I just substitute 1 into the original equation? So instead of 1 minus 4, I have, instead of x minus 4, I have 1 minus 4. Okay? And instead of x plus 2, I have 1 plus 2. So what does this give me? This gives me negative 3 times 1 plus 2 is 3. Negative 3 times 3 is 9. Oh, I lied. Negative 9. So what is my vertex? It is 1, negative 9. And Desmos says I'm correct. 1, negative 9. Perfect. Okay. Now if I want to draw a quick sketch. Okay, so I know my x-intercepts are at negative 2, 4. It doesn't have to be perfect. And let's say that's 1, negative 9. I don't know why it keeps doing that. 1, negative 9. Okay, so I know that this is also opening up because my a value is positive. So I know it's going to go something like that. Done. Okay, so let's try. I'm going to try one that's a little bit different. Okay, this second question is very similar. So I'm going to try this one. Okay, so what are my x-intercepts? Well, first off, you're looking at this and going, wait a minute. The question above, I had 2 brackets. The question down here, I only have 1 bracket. But why is that? Well, first off, I know my first x-intercept here is going to be x equals to negative 4. So I'm just going to go ahead and write that down. Now in this one, I noticed, hey, there's no bracket. Well, you can picture it this way. Okay, now you don't need to write this down. What I'm about to write down is redundant. But you can picture it as y equals 2, 2. And then instead of just a single x, it's saying it's x plus 0. And then x plus 4. Okay? X plus 0 is still x, right? Well, what does that tell me then? Though that tells me that x equals to 0 is my other x-intercept. 0, 0. Okay? Negative 0, positive 0, doesn't matter, no. Okay, again, let's follow the x-axis of symmetry. So in this case, it's going to be negative 4 plus 0 divided by 2. So the axis of symmetry should be at negative 2. Okay, now what is my y-intercept? Or sorry, my vertex. So my original equation was this. So I'm just going to substitute x for negative 2. So I'll have 2, negative 2, and then negative 2. I should have given you more space, my fault. Okay, now if I type all that in, 2 times negative 2 is negative 4. Negative 2 plus 4 is 2, so 2 times negative 4, that's negative 8. So my vertex should be negative 2, negative 8. And then if I wanted to draw a quick sketch, so I know my x-intercepts are at 0, and negative 4, and negative 2, negative 8. I'm just going to pretend it's right there. That's my vertex of negative 2, negative 8. And then again, I know it's opening up because my a value is positive. And oh, oh my goodness. Okay, so let's say it's crossing that point. Now, the one thing you got to remember is when I'm drawing these, I want to try to keep this as smooth of a curve as possible. Do not make it pointy. Alright, so that's that. Now let me scroll down a little bit further and take a look at some of these other examples. Now, in the homework questions, you might run into, I'm not going to show this one on Desmos, you can type it in yourself, but in the homework question, you might run into ones that are a little bit more complicated. I'm going to try to see if there's an example of one here. You should be able to draw the rest of these. Yep, okay. You might run into one that's a little bit more complicated. So, I do want to address the why do we switch signs. It's as simple as this. If I took a look at this question and I asked you, what are the x-intercepts? What are the or let's take a look at this one, sorry. What are the x-intercepts? You said it's 4 because that's a negative 4, and negative 2 because that's a positive 2. But why is it that we switch signs? Well, remember, all of the x-intercepts have a y value of 0. So if I backtrack, if I were asked what are the x-intercepts in this case, I know my x-intercepts always occur when y equals to 0, right? Well then, if I look at that, I would think, how would I solve that? Well, I would look at this and go, well, if I want this whole thing to equal to 0, you have to remember that 0 times anything is 0, right? Which means I either want x minus 2 to equal to 0, or I want x minus 7 to equal to 0. Well, look what happens when I solve that. Okay, well, if x minus 7 equals to 0, move that to the other side, it becomes positive, so my x-intercept becomes 7. So one of my x-intercepts is 7, 0. If I look over here, same thing. If I move the 2 to the other side, I get x equals to positive 2, which means my other x-intercept is 2, 0. Okay? And that's just simply based on the fact that all x-intercepts have a y value of 0. Yeah, and that is why the sign switches. So then why didn't I mention that from the beginning? I did not mention that from the beginning because a lot of our x-intercepts are going to be nice and solid whole numbers for now. And so this point right here is not as relevant. And a lot of you would have noticed anyway that, hey, why don't I just switch the sign? But later on, or not even later on, in your homework question, you might run into questions like this. So I'm going to make one up. 2x plus 1, and then 3x minus 5. If I were to ask you, what are the x-intercepts in this case? You would say, some of you would be tempted to say, well, it's just negative 1 and positive 5. But let's graph that in Desmos and see what happens. Let's see if you are correct. Y equals 2x plus 1 and 3x minus 5. Are we correct? Is it at positive 5 and negative 1? No. So I'm going to backtrack here and figure out how did Desmos give me these answers of negative 0.5 and 1.667. Well, it's just using the above fact that, let me scroll this up, that in order to find the x-intercepts, I want my y value to be 0, right? Which means that 0 times anything is 0, which means either that 2x plus 1 equals to 0, or 3x minus 5 equals to 0. Okay, now if I solve this, so move the 1 over, I get 2x equals to negative 1, divide both sides by 2, x equals to negative 1 half. So one of my x-intercepts would be at negative 1 half and 0. This is the same thing over here. If I move the 5 over, it becomes positive. Divide both sides by 3. X will equal to 5 over 3, which is about 1.66 repeated, which means my other x-intercept is 5 over 3 and 0, which is about 1.66. Now let's see if that was correct. Desmos 1.667, and the other one, negative 0.5, negative 0.5. Perfect. Okay, now I can already see one of you guys asking, how would I solve a question like this? Well, to solve a question like this, I could either find it in vertex form or factored form. But I'm being asked to find it in factored form, so ignore what I just said. We're going to find this in factored form. Well, y equals, do I know my a value? No, I don't. That's our vertical stretch compression. Some of you might say, well, if that's the vertex, and I go 1 over, and I'm going down 2, then my a value is probably negative 2. You're probably right. But we don't know that for sure. So we don't know my a value. But I do know explicitly what my x-intercepts are, negative 1 and positive 3. Which means I wouldn't put negative 1 here, would I? No, I would put positive 1. And I wouldn't put positive 3 here, would I? Nope, I would put negative 3. Okay? Now, our job is then to find what the a value is. If only I had another point I can sub in for x and y to find my a value. Right there. So I'm going to sub in 0 for x and 6 for y. So I'm going to have 6 equals a, and then 0 for x plus 1, 0 minus 3, and then solve. 6 equals a, 0 plus 1 is 1, 0 minus 3 is 3. There we go. 6 equals a, 1 times negative 3 is negative 3. Divide both sides by negative 3, and what do you know? A is equal to negative 2. So, those of you who guessed that right, well, good job. So here is the full equation. If you were to graph this in Desmos, you would get this exact very graph. Okay. Again, any questions, please post under math questions, and do not post it anywhere else. That way when I don't create multiple videos of the same questions. Okay. So finish this sheet and the homework questions, and yeah, good luck.